Okay, welcome back. In last class we discussed about in a previous class we discussed about the definition of lateral earth pressure and assumptions made by Rankine. And after that, in last class we discussed three cases, that is active earth pressure, passive earth pressure, and at rest earth pressure, and coefficient of active earth pressure, passive earth pressure, and at rest pressure. Okay, and in this class we will consider many cases and how to solve the problems that we'll consider. And here I am considering very simple problems to understand the concept, and later after this class in the next video I will consider the complicated problems which usually ask in examinations. Okay, na? And these questions, the problems what I am discussing in this class may not ask because they are very easy and very basic. Okay, let us go. Now look at here, the case 1 we'll consider here, that is dry and backfill is a dry soil. The backfill is dry soil, means if this is a retaining wall, if this is a retaining wall and this is your backfill. In this case I am considering, the soil is a dry, and as per assumption this is a cohesion-less soil. Cohesion-less soil means C equal to 0 soil, but there will be some phi value, there will be a gamma value, but this gamma, as I said, this is a dry gamma. These are all soil properties. These are all soil properties. Let us consider the height h, it might be from the top to bottom. Then if I consider the reference line, if I consider the reference line, this one, then I need to calculate the earth pressure distribution, from top to bottom. Okay, then by using this phi value I will calculate k value. K, either it is a ka or kp or k0, because by using a phi value I can calculate any one of these three that usually they will ask in the problems. Okay, think that we calculated k, then after that I need to calculate the horizontal stress at A and at B, because from A and B the stress will be moving. Now at A, see, always you should calculate in this way only, that is sigma h at A point is equal to K into vertical stress at A point. That is your K into vertical stress at A point, usually gamma into h. Here in this case K into gamma dry into h, for A point is 0, therefore the 0. The horizontal stress at A point will be 0. Then sigma h at B point will be equal to K into vertical stress at B point, therefore K into gamma into h, in this case K into gamma dry into capital H for the point B, therefore this is your sigma h at B. Okay, they are varying linearly, therefore I will draw the diagram. This is K gamma D into H. Okay, now what, here the total earth pressure will be acting in this direction, that is a capital P, that is your area of the earth pressure distribution diagram, half into base into height. Base is K gamma D H into height is the H, and this will be acting at a distance h by 3 from the bottom. Okay, now this is what the case 1, that is a dry soil as a backfill, as usual procedure. Now we will consider one problem, and here you see the retaining wall is 8 meter high and retains a cohesion-less soil and as a backfill, and the angle of internal friction is 35 degree with unit weight 18, and active earth pressure we need to calculate. We need to calculate active earth pressure distribution diagram, also determine total active earth pressure and its point of application. This problem we will solve. Then what are the data? The data I will write inside the retaining wall. We will have this practice only, so that the half of the problem will be understood. Okay. Here how many layers are there? only one layer of soil we observe. Only one layer of soil we observe. And the height of the retaining wall we are observing 8 meter, it is a given, and phi value here it is given as 35 degree, and gamma value is given 18 degree. Okay, 18 kilonewton per meter cube. Okay, then I will calculate Ka. Why Ka? Because active earth pressure it is asked. Therefore Ka equal to 1 minus sin phi divided by 1 plus sin phi, 1 plus sin phi. Therefore 1 minus sin 35 divided by 1 plus sin 35. The answer is 0.271. 0.271. I got Ka. Right? I'll write here. Ka equal to 0.271. Right? Now I will consider 2 points, that is a point here and this is a B point here. I will draw the reference line. I will draw the reference line. Okay. This is my reference line. Now I will calculate sigma h at A. Sigma h at A equal to K into vertical stress at A. Therefore Ka this time h in gamma into h, and this time Ka into gamma is a gamma into h is a 0. Therefore the answer is 0. Sigma h at A I got 0. Then I will calculate sigma h at B. Sigma h at B equal to K into sigma vertical at B, that is a K into gamma into H, that is your K is your Ka, gamma is your gamma D, H is your capital H. Okay, you can skip these all steps for your exam. Just for your understanding I am making a bigger one. 0.271 into 18 into 8 meter. The answer is 39.02 kilonewton per meter square. Okay, I got sigma B. Now I will draw the stress distribution diagram. This is my stress distribution diagram, and this is your 30.02. And now I want total active earth pressure, that is a capital P, and the capital P is equal to half into base 39.02 into the height 8 meter. The answer is 156.09 kilonewton. And where it is acting, which is acting h by 3 from bottom, okay. Therefore 8 by 3, that is your 2.667 meter from bottom, right? This is your problem solved. Okay, next I will go to the second problem, that is your look like the same, the retaining wall 8 meter height and have a dry cohesion soil, cohesion less, so backfill 35 degree and 18, and everything is same. I think the change what they made here is they are asking passive earth pressure. Then the problem procedure is 100% same, it goes like this only. That is your retaining wall, okay. Then here we have a horizontal stress, sorry, backfill. This is your backfill, and we'll consider the data as 8 meter height, gamma is a 18, and phi is a 35, and kp I need to calculate. That kp is a 1 plus sin phi divided by 1 minus sin phi, that is equal to 1 plus sin 35 divided by 1 minus sin 35. The answer is 3.69. Okay, now I will consider a 2 points, A point and this is a B point. Then I will draw, okay, this is the A point and B point. Now I will calculate sigma h at A is equal to K into sigma V at A, that is a K into gamma into H. In this case Kp Kp into gamma into h is 0 here, h is 0 here, therefore answer is 0. Now sigma h at b is equal to k into sigma v at b, that is k into sigma h, that is k gamma h, k into that is your kp gamma h, and now I will calculate kp as 3.69 into 18 into 8. The answer is 531 531.36 kilonewton per meter square. Okay, sigma h at b. Then I will go back here, the distribution will be, this is your 531.36. Okay, and here the total earth pressure will be capital P and acting at a distance h by 3 from the bottom, sorry. Then P equal to half into base 531.36 into height is 8 meter, then the answer is 2125.46 kilonewton, acting 2.67, that is h by 3, 2.67 meter from bottom. Okay, the problem solved. Going back to the third problem, and this I will give you as a homework, that is exactly same, 8 meter is there, 35 is there, 18 is there, but the condition given is at rest. At rest condition means k what you calculate will be k naught, that is equal to 1 minus sine phi. Then 1 minus sine phi, answer is 1 minus sine 35 is a 0.426, 0.426. You need to take 0.426 and go ahead with the same procedure. Wherever I used kp, there you use k naught and you will get the answer. Okay, then we will go to the second case. The second case, just I made it simply to understand get the difference between the moist soil and the dry soil. But here, what is the difference between the dry soil? Dry soil means there will no water. The soil is completely dry. There we will have a gamma D, and the moist soil means we will get a gamma B, bulk density. Okay, but lateral earth pressure, when we are calculating, there is not at all difference between the procedure for dry soil and moist soil. Exactly same. I could have made the heading like this. Look at here. For dry and moist soil, I can make the heading like this. For dry and moist soil, then the procedure will be same. But purposely I made it as a second case so that you should not get any dilemma between them. Okay, then here, what is this moist soil? Moist soil means there will be some moisture content. The moisture content may be a little bit or maybe maximum means when I say zero moisture content, then I will get a gamma D. Then when I say maximum moisture content, then I will say it is a gamma sat. See, this is a gamma sat. In between moisture content, in between this and this, I can say that is your gamma B. Okay, here in the previous case, wherever you used the gamma D, there you will use gamma B or gamma sat over. Then the procedure is simple. But don't consider here that, don't think that there is a saturated soil means water table is there. No, without water table also we can have a saturated density. Therefore don't think that whenever a gamma sat is given means water table is there. Okay, many students will make a mistake here. Whenever a gamma saturation is given means they predict that, or they assume that there is a water table. Okay, that's why they will start taking gamma dash and go ahead. Okay, no, don't think like that. Gamma sat is also a bulk density, that is also moist soil. Okay, no? Now if you want, here just I changed the value of that gamma from 18 to 19, and the procedure is simple and the same, and you can follow this, solve this problem. Okay, now we'll go to the case 3. Now it's very important case. Okay, important case because why? Because the soil is submerged inside the water. Okay, let us consider this is your retaining wall, this is your retaining wall, and here there is a backfill. And as I said in the heading itself, that is a backfill is submerged. Submerged means the water table must be at the top level. We'll consider the water table in the top level, means ground surface is here and water table is also here. Okay. Means on this retaining wall, there will be pressure because of water and pressure because of soil also. Pressure because of water and pressure because of soil also. Okay, but usually if pressure because of soil if you want, then you should know submerged density, and the pressure because of water you should know that is what gamma w, that is the density of water. If you know these two, then you can calculate the pressure acting on the wall. Okay, but here something very interesting thing happens between the pressure which is acting on the wall. That is, look at here. Here there is a wall, here there is a wall, and on that wall there will be a pressure due to soil. Okay. According to Rankine, he says that if there is a vertical stress at any point, then I can calculate sigma h by multiplying k to the vertical stress, then I will get a horizontal stress. This is a Rankine's theory. Rankine's theory tells that the horizontal stress and the vertical stress are not same. They are function, they are depending on each other. That if you want to calculate, then that is your sigma h equal to k into sigma v. K is not equal to 1. This is for soil, this is for soil. Then coming to the water, there is a water also here. Then what about water? But Pascal says that the water pressure in all the direction is same, means according to Pascal, sigma h equal to sigma v, sigma h equal to sigma v. Then where is a k here? K, Pascal is not using that k. Then according to Pascal, if I consider k, then that k will be equal to 1. K will be equal to 1. Understood? Now look at here, but this soil, whatever the soil is there here, this soil consists both. Here water is also there and here soil is also there, both are there. Then the question comes whether I have to follow Rankine because of the soil, then I have to consider k not equal to 1 and go ahead, or whether I have to consider a Pascal because there is the water and I can go ahead with the k equal to 1. There is a dilemma. Okay, there will be a fight between this Rankine and Pascal, saying that there is a soil, I will multiply k. Rankine says, and Pascal says that no, you cannot multiply k to that one because the water is there, water is mine, and that is horizontal and vertical stresses are same, therefore you cannot multiply k, I will not allow you to multiply k. Pascal says, how can you tell to me that soil is there, then I have to multiply k? There is a fight between these two fellows. Then the old person will come to solve this problem. His name is Archimedes. Archimedes principle, what it says? It says that if you have a gamma saturated, then you can make it into two parts, that is a gamma submerged plus gamma W. Then Archimedes says that don't fight each other, come here. Okay. First he will call Rankine and tell to Rankine that, see Rankine, for you a soil is very important, therefore you multiply k. You multiply k. But what? You multiply k to gamma dash into h. This is your vertical stress. You calculate vertical stress, and for the soil you multiply k. Either it is a Ka, Kp or K naught. Okay, then Rankine is happy. Then Archimedes calls to that Pascal, you come Pascal, that is your, in your case a water is there, you should not multiply k, therefore you make a gamma w into h only, you don't multiply to k there to that one. Okay, means we will have a two triangles here. The one triangle considering submerged unit getting the horizontal stress, and another triangle we have here, that is only with the water pressure acting on the wall, that is a gamma W into H, no multiplication of K. Then after that, total active earth pressure acting will be this P1 and this P2. Okay, this we will see in the problems how exactly we solve this problem. Look at here, the backfill is there, 8 meter height and 35 degree and 22 kilonewton, and this case they are asking active earth pressure, and they said that water table is located at a ground level. Water table is at the ground level. Let us consider the problem. We'll draw the retaining wall. This is your backfill. Retaining wall 8 meter height, and water is also there here, soil is also there here. Okay, submerged now means gamma sat is there here. Gamma sat is 22 and phi 35. Phi is 35 means I can calculate Ka, because active is asked. Ka, the same 1 minus sin phi divided by 1 plus sin phi, 0.271. 0.271. Then I have a H is over, C is 0. Okay, from this I got Ka equal to 0.271. Okay, now this data I got it. Now I will come to the point A. That point I will calculate by using the submerged condition, that is earth pressure considering submerged soil only, soil only. Okay, that is sigma H at A is 0, sigma H at B equal to K into vertical stress, that is a K into gamma into H, but in this case K is the active earth pressure, therefore Ka, and gamma here in this case is submerged, therefore gamma dash, and H is your H. Then Ka is a 0.271 and gamma dash is what? Go back here, 22 is given saturated, therefore gamma dash equal to gamma sat minus gamma W, that is your 22 minus 9.81. 9.81, sorry, 22 minus 9.81, that is 12.19 kilonewton per meter cube. That I will write here into 12.19, and height is 8 meter, therefore into 8 into 0.271, 26.427. that I will write here 26.427. okay, then we have another triangle for water, and this triangle is only because of water, that is your sigma H is equal to sigma V, there won't be any K, gamma W into H, that is 9.81 into 8. The answer is 9.81 into 8, that is 78.48 kilonewton per meter square. 78.48, I'll write here 78.48. then this is your P1 and this is your P2. Therefore, coming to here, I will calculate P1 equal to half into the 26.427 into 8, and P2 equal to half into 78.48 into 8. Therefore, P2 equal into, first I will write this one, this is 313.92, and this is 26.42 into 105.68 kilonewton and kilonewton. The total earth pressure will be plus of these two. Okay, and both are triangle, therefore H by 3 from the bottom. Right, now this problem you solve it yourself, that is everything is same, water table everything is same, but passive earth pressure is given, means you have to consider Kp here. Kp is 3.69, you will get something. 1 plus sin phi divided by 1 minus sin phi. Then I will give you another problem. If it is a saturated, same submerged unit to a soil and water table is available, but case is at rest case, then K naught you take 1 minus sin phi and go ahead. Okay, we'll go to case 4. Case 4 is backfill with uniform surcharge. Backfill with uniform surcharge. Let us consider the case. Let us consider this is your retaining wall. This is your retaining wall, and let us consider this is your backfill. Okay, there is some surcharge. That surcharge may be a building or that what your pavement or whatever it is. There will be some surcharge is there. Let us consider that surcharge is measured in terms of Q, kilonewton per meter square. Okay, this surcharge means it is a vertical stress. No, this is your always a vertical stress. That is your vertical stress. Vertical stress. Now we'll consider one point at that is at A here and at B here. Then I will solve this. Here sigma at A will be 0. Because of soil it is 0. Sigma h at A will be equal to 0 because of the soil, plus there is a vertical stress, that is a Q, and vertical stress we have to multiply K to that one. Therefore sigma h horizontal stress at A will be equal to K into Q. K into Q. Here this time it is not 0. There is a some stress here. Okay, and we will have some pressure here, that is your sigma h at B equal to K into vertical stress. Vertical stress. Then what is your vertical stress? K into vertical stress is Q is also vertical stress, and gamma into H is also vertical stress. Therefore K into Q plus K into gamma H means we will get something, a straight reference line and this line. These are all straight lines. My pen and this pad is not moving properly, that's why we will get undulated lines, but you assume it as a straight lines. Okay, now in this case I have to make one vertical line so that I will get one rectangle and one triangle. It becomes very easy to calculate total earth pressure. This is your total earth pressure. I'll solve one problem so that you will understand it. Right? Look at here. Unit weight is 19 given, and retaining wall 8 meter and 35 angle of internal friction, and surcharge is given as this much, and active earth pressure is asked. Active earth pressure is asked means Ka equal to 1 minus sin phi divided by 1 plus sin phi. Therefore it is 0.271, already calculated in the previous problems. Now come to the problem. This is your retaining wall. Now there is a surcharge. This surcharge is 10 kilonewton per meter square. Okay, reference line. This is the B point. Now come to sigma h at A equal to sigma K into sigma V. Then what is the K? K is here Ka, sigma V in the top. In this surface, at this surface is what? There is a vertical stress, that is a 10. Therefore Q. Okay, therefore it is 0.271 into 10, that is 2.71 kilonewton per meter square. This time we did not get 0, keep in mind, right? Then after that we will go to sigma h at B is equal to K into sigma V, that is a K into vertical stress at B. What is the vertical stress at B? Is vertical stress because of the surcharge and soil, that is because of surcharge plus soil. Okay, therefore first we will make it K into Q plus K into gamma H. Okay, K is a 0.271 into 10 plus K 0.271 Ka, right, into 19 into 8. Okay, we have to, we will not operate this entire thing at once. We want both the answers. 0.271, that is a 2.71, 2.71 plus 0.271 into 19 into 8. This is your 41.92. If you want, you can add. That is your 43.90. Now 2.7 is, this is your 2.71, and this will be straight line, and we will have one more line. Okay, one more line. This is your 2.71, and this is 41.92. Hello, 41.19, right? Now we will make a two diagrams, that is, one is the rectangle diagram with the P1 and a triangle diagram with the P2. Therefore I will calculate P1 is equal to rectangle 8 into 2.71. okay, that is 8 into 2.71, it is 21.68, acts at h by 2 from bottom. H by 2 equal to 8 by 2 equal to 4 meter from bottom. This we will call it as actually Z1. It is Z1 equal to 4 meter. Then P2 equal to half into, what is the height, 41.19, half into 41.19 into 8 meter. Therefore 41.19 to 8 into half is 164.76 kilonewton. Then acts Z2, that is h by 3 from the bottom, 8 by 3 from the bottom, 2.67. okay, then the total pressure P will be equal to P1 plus P2, that is your 21.68 plus 164.76, that is 186.44. this is your total pressure acting. Where it is acting, we will call it Z bar, that is P1 Z1 plus P2 Z2 divided by P1 plus P2. I will not substitute, I will directly calculate. You need to substitute P1 value here, P2 value, Z1 Z2 and P1 P2, then you will get the answer. The answer we are getting 2.82 meter from bottom. Okay, go back to the problem here. Means here we got, that is the total pressure acting here, that is your answer was 186.44. the value is 186.44 and acting at a distance 2.82 meter from the bottom. Problem solved. Okay, take one more homework problem here. This the same problem you solve it considering passive earth pressure, right? Now coming to the backfill with sloping ground. Okay, in this case this will be a retaining wall. The hard strata will be here, but this ground surface will be inclined, that you can consider inclined, and the horizontal angle with respect to horizontal surface, this inclination will call it as a beta. That will consider beta, means your ground surface is at this level. Then how to deal with this problem? Okay, this problem we can deal with by this alteration. We will draw one more line which is parallel to the ground surface. See, this line is parallel to the ground surface. And how we need to achieve this one? By just drawing a line with beta with respect to horizontal from the heel, from this point, right? We draw this one. Then after that you just forget about this vertical, and you will have a retaining wall in this case. In this way you will have a retaining wall in this way, that is perpendicular to the these two surfaces. Then think that you have a retaining wall in this way, okay, for the calculation purpose. Then after that you do all the you follow all the procedure how to solve the problem for that retaining wall, no? You will draw this one, and you will draw this horizontal, this one horizontal stress at the bottom and the top. You will calculate this one into as a k into gamma into h, and this will be 0. And you will calculate p again, that is also parallel to the top surface, and the p you will calculate, and this distance is again h by 3, you know. You will follow each and everything as usual. But what is the difference here is the ka or a k what you calculate here, that is not like 1 minus sin phi divided by 1 plus sin phi. K is not like this, wrong. Kp is not like 1 plus sin phi divided by 1 minus sin phi. Kp is not like this, but we need to calculate these two k by using a different formula, that ka is equal to cos beta into cos beta minus square root of cos square beta minus cos square phi divided by cos beta plus square root of cos square beta minus cos square phi. By using this formula we need to calculate Ka. Okay na? And that Ka you are using everywhere wherever it is required, then the problem is solved. Then what about Kp? Then Kp will be equal to 1 by Ka. Kp equal to 1 by Ka. Right? Then by doing this you will get one that p value, and this value will get first, and later that you will get p value. And look at here, that p value is acting in this direction, and the angle is beta value. And if you are interested in a horizontal stress, then you convert it. If it is a p, then the horizontal pressure will be, this will be how much, that is a p cos beta is your final answer. P cos beta will be final answer. Right? This is backfill with sloping ground. We will solve one problem here. 10-meter retaining wall is there, and angle of internal friction 35, density 19, and ground surface is inclined at a 15 degree and to the horizontal. Draw the active earth pressure. Okay, draw active earth pressure distribution and determine total active earth pressure they are asking. Right? Now look at it. This is your retaining wall, and this is your ground surface 15 degree. Usually this is a horizontal line, and we need to draw one parallel line. Okay, then we will get a parallel line here, and we will draw one more reference point A here and one reference point B here, so that this is your perpendicular to the ground surface line. Then we will calculate Ka is equal to cos beta into cos square beta minus square root of cos square beta, sorry, this is cos square beta minus cos square phi divided by cos beta plus square root of cos square beta minus cos square phi. Then phi equal to 35 degree and beta equal to 15 degree. You substitute and you will get a Ka equal to, we will get 0.29 value, 0.293 we will get as a Ka. Then what we need to do, we will go with a sigma h at A is equal to sigma k into sigma v, that is your 0. Then coming back to sigma h at B is equal to K into sigma V, that is your K is what, 0.293. How to calculate sigma V? That is, here gamma is given 19. This time the height is given 10 meter. 10 meter. This is your answer. Into 19 into 10. 55.67. 55.67 kilonewton per meter square. Okay. Then you got this distribution diagram this way. Okay. Then we need to calculate a capital P. That capital P will be equal to half into 55.67 into 10 meter. That is 278.37, and this Z1 will be equal to 10 by 3 from the bottom, that is 3.33 meter. Okay. Then after that what we do, we will draw that diagram first. This value you got it. How much? 278.37. Okay. Now actually you want horizontal stress, but right now we calculated this P. This is your 278.37. This angle, this is your 15 degree beta value. Then if you want horizontal stress, that is the pH. If you want, then that is 278.237 into cos beta, cos 15. This into cos 15. That is your 268.88 kilonewton is the final answer. Okay. And there will be one vertical component also. PV, that also you can calculate. That is your 278.37 into sine 15 over. Okay. The problem solved. Now the last one, here is a case 6, the inclined back of the retaining wall, horizontal ground surface. Okay, look at here, the retaining wall is usually this side will be like this. We don't consider this side, but if the back of the retaining wall is inclined, retaining wall is like this, then let us consider this is your theta value. Usually this theta value is called as a batter angle. That is called as a batter angle. Okay, this is the theta value, and ground surface, that is your back of the backfill, will be horizontal surface we'll consider. Then how to deal with this problem? The problem is very simple to deal. That is, we need to draw one vertical line at the heel point. Okay, we'll draw this one. We will call this as A, and this is the B, and this is the C. Now for this BC line, consider that this is the back of the retaining wall. BC is the back of the retaining wall, and follow your procedure. That is, your top and bottom you will consider 2 points, and you will draw stress distribution diagram and draw pH. PV you will calculate, P you will calculate by considering something like that. Then K, gamma, H and R. And after that, then here we need to think. This ACB triangle, ACB is there, no? That into 1 meter if I do, then I will get a volume of that one. Then I will get a volume of ACB, I will get. Perpendicular to the board, 1 meter if I do, then I will get a volume. Then this volume is multiplied to density, then I will get a PV, I will get it. I will get vertical pressure, total vertical pressure, or otherwise weight of the wedge, that weight of the ACB triangle, you will get it. Then once you get a ACB, that is a weight of that one, that is a PV, and you will get a horizontal stress by calculating, considering the BC as a retaining wall, then you will get a pH over. This is your pH and this is your PV, and exactly if you want resultant, then you can calculate this resultant. R is equal to square root of PV square plus pH square. PV square and pH square. Then where exactly this will be acting? Where exactly this will be acting here? The very simple, that triangle portion CG will be here. You draw one line, that CG line here, and this P is there, P line you draw, and both will coincide actually one point, and at that point the stress will be acting. At that point the stresses will be acting. Okay, this is all about case 6. We have one problem on this, we'll solve this. This is the 35 degree and 19 kilonewton. Batter angle here given is a 10 degree, and determine active earth pressure. Okay, then we'll solve this problem. We'll consider the back of the retaining wall inclined, and this is your batter angle 10 degree. Backfill it is. Right. This is your backfill. Right? Backfill. Now we'll draw one vertical line here, and we'll consider C and A, B as your retaining wall. Then we'll consider A point here and a B point here. This will be my reference line. Okay, na? Then sigma first Ka I need to calculate. That Ka equal to 1 minus sine 35, 1 divided by 1 plus sine 35, 0.271. Okay, then sigma h at A will be 0 because top surface, and sigma h at B will be equal to K into vertical stress. K is a 0.271. This is gamma into h. Gamma is how much? 19, and h is 10 meter. H is 10 meter. Okay, then I will get 0.271 into 19 into 10. I got 51.49 kilonewton per meter square. Okay, then I will calculate P is equal to half into 51.49 into 10. The answer is 257.45 kilonewton. This is your pH. This is your horizontal stress. Go back, you will get a distribution diagram this way. This is your 51.49, and this is your P. This is your pH. Okay. Now for PV, what I have to do? For vertical stress, this triangle is there here. This is A, B and C. This angle is 10 degree because the given here 10 degree means this is 10 degree. Then this height is 10 meter. Okay, then I have to use which trigonometric function? Tan theta. Tan 10 degree is equal to opposite is AC divided by adjacent 10. Therefore AC equal to 10 tan 10. 10 tan 10. That is 1.763 meter. Okay, then what is the volume of that wedge? Volume of ACB is equal to half into 1.76 into 10 meter. Okay, this into, that is your 8.816, actually into 1 meter now, because perpendicular to board 1 meter. This is your meter cube. Then PV will be equal to density into volume. Density is a 19 into volume is 8.816. Therefore 167.51 kilonewton. Then you got PV and you got pH. Therefore the resultant R will be square root of PV square 167.51 square plus 257.45 square. Therefore the answer is 307.14 kilonewton. Check it. Okay, this is all about the cases. and we'll solve few problems on this sand only, that is your cohesion less soil only. Then we'll go to the next concept. Thank you.